Okay, yeah, thank you for this opportunity. I'm Jim Watkins. I'm at Cornell University, representing the group that is led by Lars Rudstrom, and also note the leadership of Peter Esselman from USGS on this project, as well as Daniel, Tim O'Brien, and Dave Warner and Mark DeFore from various lake efforts. So we're going back to the sail drone on this talk. So again, you see this diagram of the sail drone capacity with the atmospheric measurements, the lake measurements, including chlorophyll and temperature, as well as the main payload that this talk will be about, which is the Simrad 120 kilohertz hydroacoustic payload, which is in the hull. So Dan talked about the 2022 survey, which had the comparison of the ship and the sail drone. So by 2024, this was our first chance to really test out a lake-wide survey of Lake Superior. And currently, so this is by 2 sail drones that lasted 43 days between late August and October. So traditionally, we only use the night data for fisheries surveys. And this data is currently very close to publication, as Dan presented it at the Lake Superior session. So it actually represents a lake-wide fisheries assessment for the entire lake. However, we did collect twice as much data. We have a lot of daytime data. So this talk concerns what can we benefit from this 50% more daytime data. And I'd like to start off by just focusing on one of Lars's interests. We've really been amazed at the ecological insights that we've gotten out of this data, particularly the interactions between gorgonids and mysids. So I'm going to show a few examples of echograms from these 4 circled areas in Lake Superior. These are 4 successive days. So not only is it showing the sail drone passing through space, but it's also time. So each one is 1 full day. The red is the lake bottom. These are relatively deep sites, more than approximately 200 meters deep. And immediately you see a very sharp blue line near the thermocline. That's the mysid swarm. So that's the backscatter coming out of the mysids. And you see the full migration, both at sunset and sunrise on either side of that. So we're going to zoom in a little more to get a little more focus on things. So not only do we see the full mysid migration, remember that there are a lot of fish within that mysid layer and above that you can't quite see yet, but we'll narrow in that. But you do see a nice layer of fish just above the daytime mysid layer. Basically, they're larger organisms, so the fish are larger than the mysid invertebrates, so they have a more red color, which represents target strength. So, but you have a really nice layer of fish. There has been apportionment during this time, mostly in central Lake Superior, and many of the fish caught in midwater trawls were either cisco or smaller kai. But this was, again, collected at night. So, so a cool thing that we're seeing is that the kai, we believe, are migrating great depths as co-evolved with the mysid prey to chase these mysids. So one new insight that we developed is that the mysids don't migrate fully down to the bottom at these great depths, 175 meters, for example. You see this blue cloud above the red bottom. That's actually representing hovering mysids up to 10 meters above the bottom. And this next circle represents the kai that are quite a bit above the mysid layer. But there is, and this is actually starting a divergent migration before the mysids come up. And this is basically at sunset. And then again, there is another circle up here representing the cisco, which are between 50 and 75 meters, so they don't nearly migrate as much. So we were able to follow these migrations to detect Kai migrating at approximately 1 meter per minute. Mysid's going a little faster, 1.5 meters per minute. So basically, it's taking 2 hours every night and day to get from either the bottom to the surface or the surface to the bottom. And the circle, so we've really zoomed into this Mysid layer at night. You see there's kind of spattering of red targets above that green Mysid swarm. That's actually a mixed population of Kai and Cisco above the Mysid layer. And that's basically the basis of the fish measurements that we used in the fishery assessment. When we turn to dawn, when the Mysids are basically escaping, they're going down to the deep, dark abyss to escape visual predation by fish, but the Kai do follow them relatively quickly. Yeah, there. And there's also a kind of a grayish cloud. These are even smaller than the Mysids. We believe they are Limnocalanus macruus, a large calanoid copepod. And then we also have Cisco schools that are, so during the day, a lot of the forage fish actually pull up into the schools, which is a very common aggregation. Another interesting observation during the day for the Mysid layer is it's not just a single Mysid layer. We see some Mysids going hard bottom as we expect, but others staying hovering above. And then again, the Kai layer is very, well above the main Mysid layer, but there are individual excursions or forays into the Mysid layer. We're also seeing some interesting things about the Mysids at night, the Mysid layer at night. So notice it's kind of raining down as the night progresses. So it's almost like the Mysids are getting their fill and settling out of the water column. So, it'd still be caught by a Mysid net at night, but definitely a different distribution than we might expect. So turning to some ecological insights, the timing and the speed of migrations are consistent across the entire Lake Superior. We are looking at things like moonrise and moonset to detect, reasons why the Mysid layer is at the depth it is. We do see during the night the Kai and Cisco are mixing during the night above and within the Mysid layer, but during the day the Kai are going to great depth. It seems like about 150 meters, while Cisco remain in schools much shallower. And we do see some fish move into this deep Mysid layer during the day. The Mysids we see not just on the hard bottom, but also 10 meters above the bottom. Caden will talk about this pattern in the next talk. And perhaps they're avoiding the bottom to avoid predation by sculpins, for example. But this has real implications for our thoughts of Mysids as a coupler of benthic and pelagic habitats. And then we see this Mysids descending before dawn, perhaps satiation. And now we're going to shift to the primary question of this, a very applied question is, can we use the day acoustics for fish assessment? So there are commonly used day acoustics in marine surveys that operate around the clock. And there are a few examples of lake surveys, for example, a deep perched layer in Czechia and lake trout in Canada and the Western lakes. So the way we approach this is to basically directly compare the backscatter that we see on the surveys during the day and the night for specific day-night cycles. So these are two examples. The blue box represents the night. The red line is the upper 100-meter backscatter, whereas the faint blue line down near the bottom, which is much lower, is the 100 to 200-meter backscatter. So we see that day values are generally less than night values. In the first case, it's 28%. In the second case, 42%. You can see quite a bit of variation over the transect, and that's pretty common for just variation of fish abundance. And this, again, is removing the Mysid contribution to this whole thing. But we do have cases, other days, where days and nights are quite similar. So notice, again, the blue box represents the nighttime. But during the day, on either side of that, you do see pretty big peaks that are caused by these Cisco schools that are occasionally seen. And out of the 43 day-night cycle for the two different drones, we've done 6 comparisons so far, in which 3 of the 6 comparisons, the green is the night, the orange is the day. We generally see significantly higher values of fish backscatter during the night than during the day. So what could be causing this daytime acoustics being so much lower? So we explored 3 different reasons. One is that perhaps the fish during the day are either going hard bottom or maybe hiding out in the surface blind zone. And to avoid, being the acoustics can't detect them in those 2 places. A second thing is that with migrating fish, when fish get deeper, their swim bladder compresses, and that could lead to a lower target strength, which could actually change the estimate of the fish. And the third thing is that in situ target strength is just not representative of the fish present. So our first case is actually really well represented in Huron, which is has a much larger bloater population. And the lower box basically shows that bloater going hard bottom near early on. And then we also see epilemnetic fish disappear. That's the upper rectangle. So we don't think we're seeing this in Lake Superior as much, particularly with the bloater. We're not seeing that behavior in echograms. But the second explanation we do think is a big thing, particularly the chi. So the way we tested that is to actually follow the fish during the migration and evaluate how does their TS target strength change as we look at this from deep depths to shallow depths. And when we organize that, target strength is on the bottom axis. If you look to the right, you'll see the upper part is the nighttime, which is a less negative target strength, so it's a bigger target. But then during the dusk, dawn migration, and during the day, the same fish basically shifts 4 dB less during the day. So it actually leads to a lower backscatter of 40%, which is similar to what we've seen. And our general observation so far in these 6 that we've explored is that the daytime is 10 to 80% in 6-day periods. So we do feel like this is a strong reason and can be adjusted for. Finally, there is when schooling can actually affect the target strength as well. So the daytime can be much lower fish density than the nighttime target strength because of that. So that likely is contributing and can be adjusted as well. So some takeaways is for this potential use for day acoustics. We are pretty confident we can use this in certain systems, such as Lake Superior, that need water deep enough that we can use the daytime after accounting for changes in this TS with migration. We do expect more variability due to schooling, but we are relatively confident with the Chi Cisco system in Lake Superior that we can use this adjustment. However, in Lake Huron with the bloater population, we feel like the daytime data is biased, even more biased low. Currently, we're evaluating data from all 5 Great Lakes. including some Ontario daytime data that we have, and and we are developing a new SOP for this. So we really feel that the daytime with drones was a great opportunity. We are able to separate Kai from Cisco. We increased spatial coverage by twice, and we gain a lot of ecological insights. So I'd just like to conclude by thanking you all, and this next talk will be more about Mysid ecology by Caden Asworthy. And Lars has discovered Kai is his new favorite fish. So thank you very much.